fracture. Last lecture was on the different types of fractures. This is how a bone actually will heal once it has been fractured. And we're also going to talk about some homeostatic imbalances that can occur. The very first stage in healing a bone fracture is something called hematoma formation. Hematoma is a clotted mass of blood cells. And so basically, if you fracture a bone, because it has such a good blood supply, you're going to break a blood vessel. And so a hematoma will form. It will become swollen, painful, and inflamed. If you've ever broken a bone, you know what I'm talking about. And then we are going to start healing the bone. So we need to, the hematoma forms, and we're going to repair those blood vessels eventually. But then something called a fibrocartilaginous callus forms. So fibrocartilage and fibrous tissue is going to come and basically grow in between the two bones that are now no longer connected. During this time, the capillaries are going to grow into tissue, and phagocytic cells they're going to come in and clean out any of the debris that's left, any of the parts that need to be destroyed. Then finally, something called a bony callus form, and it says new bone trabecula. And if you remember, trabecula was the bony portion of a spongy bone. And so it's a bony callus, but it's a spongy bone callus at the beginning. And then, and it's going to replace the fibrocartilaginous callus. And then eventually it's going to convert into the bony callus that's going to be compact bone. A bone callus begins about 3 to 4 weeks after injury. So normally if you break a bone and you're able to just cast it, they usually have you wear a cast for about 6 weeks. And that's so that we can make sure that that bone callus will continue to form, because it continues all the way for 2 to 3 months. But at least they know that it's formed within that 6 weeks, so that that union is going to be strong enough for you to use that bone. Then what's going to happen, you have osteoclasts. And osteoclasts are the ones that are removing calcium for the bone. They're going to come in and they're going to start helping to remodel the bone, because as that bony callus is being placed into the bone, it's not necessarily shaping the bone correctly. You might have some excess bone protruding from that area. So that is going to happen. Those osteoclasts are going to come in, they're going to clean everything out, and then we're going to have a very strong bone again. Now, unfortunately, there can be other types of bone problems instead of just fractures, but these are homeostatic imbalances. So that's, we talked about osteoclasts and osteoblasts, either putting calcium in or taking calcium out to regulate blood calcium levels. When we're doing this, or our bodies naturally do this to stay in homeostasis, to maintain homeostasis. But every once in a while there are disorders that can kind of get that homeostasis out of whack. One of the disorders is called osteomalacia. And this is basically where you end up inadequately mineralizing your bones. What happens is that the bones are not hard enough to withstand all of the weight of the body. And this can be caused by insufficient calcium in the diet or vitamin D deficiency. Vitamin D is synthesized by your skin, as we learned before, and it helps us store calcium in our bones. Another homeostatic imbalance is called rickets. And again, this is usually a children's disease. Osteomalacia can be an older individual, but bones of children are again inadequately mineralized. As they're forming, because kids' bones are still forming, a lot of times their legs will bow, and there might be some other deformities of the actual skeletal system because of the fact that they are still growing and forming. And if there's going to be any places where it bends or moves, then it's going to ossify that way later in life. And again, it's caused by the exact same thing as osteomalacia. Osteoporosis is one of the most common homeostatic imbalances where basically we are our osteoclasts, those are the ones that are reabsorbing the calcium or breaking down calcium to release it from the bones, is outpacing the osteoblasts or bone deposit. So we're taking the calcium out faster than we're putting it back into the bone. And a lot of times this occurs in post-menopausal women. Menopause is when women stop ovulating and stop having their periods. And what happens is with this homeostatic imbalance, it's a hormonal imbalance most of the time in women, and the bones can become very, very fragile and be easily broken. For osteoporosis treatment, because it is quite common, you want to take calcium supplements and vitamin D supplements, because those are going to both help with storing that calcium back in the bones themselves. Increased weight-bearing exercise. Anytime you put any stress, this is that Wolff's Law, anytime you put stress on a bone, the place where there's the most stress, there will be bone building in that one area. So the more weight you place on the bones, the stronger that they will always be. And then hormone replacement can definitely help with osteoporosis. One more type of disease or homeostatic imbalance. This is the opposite of osteomalacia, where we're going to put too much calcium back in and we're going to have excessive bone formation. And what's going to happen is you're going to get these knobs and that form on the actual bone, and it can cause, where the bone is forming, it becomes very strong, but in order for that bone to form, it's taking some of the minerals out of other places, and so you end up having these kind of weakening areas of bones. And it says osteoclast activity wanes, but osteoblast activity continues to work, meaning that you are not taking out as much of the mineral as you are putting into the bone